In this lesson, we'll explore firewall policies and hierarchical firewall rules in Google Cloud through a practical hands-on demonstration. Let's start by understanding how to set up our testing environment. First, we need to go to Compute Engine to create a couple of virtual machines, or VMs, for our demonstration. While the system enables the API, we'll take a moment to look at the firewall rules. We want to start with a clean testing environment where our internal resources cannot communicate with each other. There's an important default rule we need to discuss, the Allow Internal Firewall rule. This rule normally allows any instance on our network to communicate with any other instance on any port. To make our demonstration clearer and simpler, we're going to delete this default rule. Now let's set up our first virtual machine. We don't need anything powerful for this demonstration. Even a small VM with shared cores will work perfectly fine. The key thing to remember is to use the standard networking setup, including an external IP address. This external IP is important because we'll need it to download packages and perform our tests later. While our first VM is starting up, we'll create a second one. We'll put in the same region as the first VM, though this isn't critically important. Google Cloud uses a globally oriented network architecture, which means the region choice won't significantly affect our demonstration. Once both virtual machines are running, we'll connect to them using SSH, Secure Shell, and set up basic Apache web servers on each one. After installing Apache, we can test it by using the curl command on localhost, which should show us the default Apache 2 homepage. To make our demonstration more clear, we'll modify the default page to show the instance name instead. For instance, on our first VM, we'll make it display instance 0 when we use curl to access it. This creates a simple HTTP server running on port 80. We'll repeat the same setup process on our second instance. Here's where things get interesting. Since we removed the default VPC, or Virtual Private Cloud, rule earlier and haven't set up any new firewall rules for internal traffic, our instances can't communicate with each other. We can prove this by trying to curl the internal IP address of instance 2 from instance 1. Even if we specify the exact port and protocol, the connection won't work because we don't have any firewall rules allowing this communication. To help understand how standard firewall rules work, let's create a basic example. We'll set up a rule that allows all traffic between instances on our default network within a specific internal IP range. For this demonstration, we'll focus on TCP port 80, which is the standard port for web traffic. After we create this rule, we should be able to curl or connect between our instances in both directions, from instance 0 to instance 1 and vice versa. However, these standard firewall rules aren't the main focus of our lesson. They just help us understand the baseline functionality. Let's move on to the more advanced topic of firewall policies. Firewall policies are special because they can work at either a regional or global level, can be attached to multiple projects and VPCs, allow for resource hierarchy-based firewall rule tiering, and enable Layer 7-based advanced firewall setups. Within these policies, we can create groups of firewall rules. It's important to note that we have the flexibility to add more rules even after we've created the policy. Let's look at some example rules we've already set up. We have rules that allow traffic, egress, to go out to several internal ranges, and similar rules that allow traffic, ingress, to come in. One particularly interesting rule in our firewall policy uses Google Cloud's threat intelligence to block traffic from Tor exit nodes. Let's break down what that means in simpler terms. The Tor network is a system that helps users browse the internet anonymously. However, in our case, we don't want to allow traffic from Tor because it could potentially be used by malicious users to access our network. Similarly, we block traffic from IP addresses that are known to be harmful. This means if someone tries to access our web application through either Tor or these known malicious IP addresses, they'll be blocked because we consider them potential security risks. We also protect against harmful outgoing traffic. This is important because if an attacker somehow gets into our system, we want to prevent them from sending our data to dangerous external locations. Think of it like having security guards who check both people coming in and anything being taken out. The policy includes additional security features such as blocking traffic from certain countries. For example, we can automatically deny access from sanctioned countries like North Korea. These next-generation firewall features give us powerful tools to control who can access our network. The next step is to connect our firewall policy to a VPC network. This connection is what makes our rules active and working. After setting this up, we can review all the rules we've created within the policy, including our default rules for traffic entering and leaving our network. Here's something interesting. Our traffic can descend the firewall hierarchy with what we call go-to-next policies, which allow traffic to continue to the next level down of the firewall. The top level is organization-level firewall policies, then our folder-level firewall policies, project-level firewall policies, and finally, classic firewall rules. To fine-tune our setup, we can create a new firewall rule specifically for internal traffic, similar to our initial configuration. Let's create this rule with a priority number of 4200, placing it below our existing rules in terms of importance. In Google Cloud's firewall system, lower numbers mean higher priority, so this rule will be evaluated after rules with lower numbers. One advanced feature worth mentioning is Layer 7 inspection. This allows us to examine traffic at the application level, giving us more detailed control over our security profiles. When we set up our new rule, we'll configure it to apply to all targets or resources in the networks associated with our firewall policy. However, we'll add a specific condition. The traffic must come from a designated internal IP address range, and will only allow TCP traffic on port 80. Once we've created this rule, we need to associate it with our default network. We can also add a helpful description to the rule to document its purpose. The Google Threat Intelligence features give us additional options for control, such as the ability to block traffic from VPN connections if needed. For geographic control, we can manage traffic by country. After we've added a clear description to our firewall rule and saved it, we should test our configuration by trying to curl between our instances again. However, we run into an interesting problem. Our rule isn't working as expected, and here's why. Our policies for internal traffic are set at too low a priority. Since these rules have a high number, meaning low priority, the system processes other rules first, never reaching our new rule. To fix this, we need to adjust the priority of our rule by moving it up in the hierarchy, giving it a lower number. Here's an important concept about hierarchical firewalls. If we created a deny rule for internal traffic in a higher level policy and associated it with our VPC, it would override our allow rule at the lower level. This is because higher level policies take precedence over lower level ones. This hierarchical structure gives us powerful and flexible tools for controlling network traffic. This system of interacting policies and rules provides network administrators with extensive options for controlling traffic flow within their Google Cloud environment. The ability to layer rules and policies with different priorities allows for very precise control over network communications. If you'd like to support the channel, consider starting a free trial of our new design tool, which is linked in the description, and let us know what you think. Thank you very much for watching to the end, and please enjoy responsibly.